Okay, so today we're going over the final exam review. So let's start off with the first question. So here we're looking at this diagram of the two parallel lines and the transversal. So in question number 1, they're asking you what angles are congruent to angle 3. So if you look at angle 3 here, all the angles that are congruent to 3 are the ones that are crossed like this. So we know angle 1 congruent to 3, and same thing down here. So those four angles are congruent to each other. So what we say here, to angle 3, the angles congruent are angles 1, 8, and 6. Okay, next one says, what theorem justifies that angle 3 and angle 6 are congruent? So 3 and 6 are, so 3 is right here, 6 is right here. And remember those two angles in that position like that? They're called corresponding angles. Okay, now they're asking us for angles 4 and angle 5. So if you look at 4 right here and then 5 right here, those are both on the inside of between the two parallel lines, but on opposite sides of the transversal. So those are called alternate interior angles. Okay, now they're asking us number 4 for 1 and 6. So 1's right here, 6 is over here. So those two are on opposite sides of the transversal, but they're on the, think of it like the outside of the two parallel lines. So here we call them alternate exterior angles. Okay, and on number 5 it says, what theorem justifies that angle 3 is supplementary to angle 5? So let's remember the word supplementary. Remember the word supplementary here means 180 degrees. So here angles 3 and 5. Okay, so angles 3 and 5. So it's this angle right here, this angle right here. So those two are on, think of it, they're on the inside, interior, but they're on the same side of the transversal. So those we call same side interior angles. Okay, so let's go on to the next questions. Example 6. So here it says, if angle 8 is 130, what is the measure of angle 1? So here we have 8 and then angle 1 right here. That means if 8's 130, so this is 130 degrees. Angle 1 is also going to be 130, since they're both congruent. Okay, so next question, I tell you if angle 7 is 54, what is the measure of angle 5? So in this one, I tell you 7 is 54. So angle 7 here is 54. Okay, what does angle 5 measure? So remember 7 and 54, they're congruent to each other. So 7 and 5. So that means that 5 is also 54 degrees. And the next question, so they tell you that angle, now this is angle 5 again, but this is a different measure. This time I'm going to tell you angle 5 is 57. Asking what is the measure of angle 4? So if number 5 is 57 this time, so we look at angle, so angle 5 here, and angle 4 here. So remember, those are congruent. So if 5 is 57, that means angle 4 is also 57. Okay, so let's go on the next one, number 9. Okay, so here they're asking us, give a pair of angles that form a linear pair. Okay, so linear pair means that they form a line or 180 degrees. So this is give a pair, so we're just looking for two angles that form a linear pair. So we could say angles 1 and 2, or like 8 and 7. So if you look at here, 1 and 2, these two together, they're adjacent, but they also form a linear pair. They form a straight line. Or we could also say 8 and 7. They also form a straight line or 180 degrees. Okay. And remember, there's a lot other pairs you could pick, but those are just one pair that you could give. Number 10, it says give a pair of angles that are supplementary. So remember, supplementary again means 180 degrees. So again, we could use the same ones from 9, or we could give other angles. So here we could also say angles 5 and 6. And again, we could say 8 and 7 again, because linear pair and supplementary, here they both mean that they add up to 180 degrees. Okay, and now give a pair of angles that are vertical. So remember the word vertical, remember they're congruent. Remember the vertical angles are, remember they're congruent. But when you look at the angles, these angles are across from each other. So a pair here that you could use is like 1 and 3 or 7 and 5. So it could be, let me say like 1 and 3. So it's these like that, 7 and 5, these like that. We could also have gone with these or with these. So those are all vertical angles right there. Okay, so next question. Okay, so here it says, what is the slope of a line parallel to y? So when you look at this problem, we look for the slope. So the number in front of the x, that right there, is your slope. Okay, let me just write that down. So when they ask you, what is the slope of a line parallel to y? So first thing you know is that parallel lines have the same slope. So when it says what is the slope of a line parallel to y equals 2/3 x plus 1, we just say the parallel slope is 2/3. So it's the same slope. Okay, on 13 it says, what is the slope of a line perpendicular to 3/4? So again, this is your slope right here. And then when it says, what is the slope of a line perpendicular to 3/4 x minus 5? We say perpendicular lines have opposite reciprocal slopes. So when we say, what's the slope? We have to turn it around, take the reciprocal, and then find the opposite sign. So if it's positive, we'll get a negative over here. So one's positive, one is negative. Okay, and then in 14 it says, what does it mean for two lines to be perpendicular? Here we just say two lines that intersect at a right angle and have opposite reciprocal slopes. 15 says, what does it mean for two lines if two lines are parallel? So it says two lines that never intersect and have the same slope. And on 16, it says, what transformation maps ABC to A prime, B prime, C prime? And we're going to give a rule for the transformation. Okay, so first thing we're going to do here is look at how we go from one point to the other. So we're going to start at, we have to pick one point. So we start at A, and you're going to see how we end up at A prime. So here it doesn't look like it reflected. Still, the orientation is still the same. There's no rotations here. So what happened here was a transformation, a translation, I mean. So remember, we always go left and right first, up and down last. So we're going to get from A to A prime. So I'm going to go to the left. So I just count the number of spaces. It's 1, 2, 3, 4, 5. So I went 5 to the left. And I went up 1, 2, 3. And I went up 3. So we say here 5 left. And then 3 units up. So when you describe that, we say there's a translation of 5 units left and 3 units up. And then just remember, if we go left, you put a negative. If you go right, you put a positive. If you go down, it's negative. If you go up, it's positive. So now a translation, we can write it in two forms. Vector form, we just put it like that. So remember, we put left and right first. And then over here is going to go up or down. So we went 5 left, 3 up. So that's in vector form. In component form, you write the rule like this: xy to x minus 5, y plus 3. Okay, now next one, 17. Says what transformation maps ABC to A prime, B prime, C prime? So here what it looks like happened, the orientation's different, but A and C are still, AC and B, they're still on the same, above or below the top. So what happened here was a reflection across the y axis. So here we say it's a reflection across the y axis. And then the rule here is just xy to negative xy. Okay, 18 says what transformation maps ABC to A prime, B prime, C prime? So here, this looks like it's a rotation. But so we start here and we go over 1, 2 quadrants. So that means it's going to be a rotation of 180 degrees. And the rule for this one is xy to negative x, negative y. Okay, so now in the figure below, it says what additional information is needed to prove that triangle SOR is congruent to triangle POQ so we want side angle side. So you want side angle and then side. So let's look at the information they give us in the triangle. So far they give us this right here, this mark, which means that this is a side. So a side. Okay, next thing they give us is this mark right here, angle O, on either end, they're vertical angles. So this is an angle. There's another angle right here. So we have a side and an angle. We need one more side. So what we need to do here is we need a remaining side, which means we need RO and OQ to be congruent to each other. So we need this final missing piece to get our third side. So that means that this side needs to be congruent to this side, which means this will be our side, and then my side. So this will give me side angle side and side angle side, which makes the two triangles congruent. So I need to have RO congruent to RQ. Oh, I put the wrong thing there. Never mind. Okay, cross this out. So actually say the wrong letter. I should say Q. QO. Yeah, you need these two sides to be congruent to each other. Okay, now number 20. So it's in the figure below, what additional information is needed to prove that triangle ABC is congruent to triangle DEC by angle side? So here we need angle side. So far they give us a side, which is right there. So that's our side. Okay, so now we need an angle and another angle. So we know that these two right here are congruent to each other because they're vertical angles. So this is my angle. So far I need my angle, I have my side, and I need one more angle. So I could either say I could either use A and E. So it could be this angle right here. So that'll give me angle side, angle side. Or another possibility, I could also say that I could use angles B and D to be congruent. So angles B and D to be congruent. That way these two will give me my second angle. Angle going up, angle side. Okay. I should put 3 marks here and 3 marks here. Okay. And now on 21, it says in the figure below, what triangle congruence theorem proves that triangle ABC and CDA are congruent to each other? So if you look at the information they give us, so if you look at this part right here, so far that's a side that both triangles have in common, congruent to each other, corresponding. Okay, we have another mark here, which means it's another side. And now last thing they do here, if you notice, the two triangles, they both share a side. So we can mark that, as we could say, we can mark this with 3 marks. So this is the third side that they both share in common. So we say first is that since AC is shared by both, we say AC is congruent to AC by the reflexive property. So since now we have side, 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 3 sides in common between the two triangles, we say triangle ABC is congruent to triangle CDA by the side, side, side congruent theorem. Okay, and that's all our notes for today.